Hello Science 10 students. Here is your first video for our physics flipped classroom. Today we're going to learn about scalar and vector quantities. Who needs this kind of information? Pirates need this kind of information, because if they need to make a map of where their treasure is, these vectors are very important for them. So what do you do for these videos? First of all, get a pen and paper ready. Then you're going to watch the video, take down any important definitions or notes that you need, and the worked examples are really important so that you have an idea of what to do tomorrow in class. You can watch this video as many times as you like, or even pause it anywhere to write down your notes. Tomorrow we're going to work together through the assignments as you already have the basic information. So scalar and vectors. When we look at the motion of objects, which is what we're doing in physics, we can define the motion as either a scalar quantity or a vector quantity. A scalar quantity only tells us the size or the amount, like 12 or 15 meters, but it doesn't describe the direction of the motion. The scalar quantity that we talk about in physics is distance, so 100 meters, 2 kilometers, but it doesn't tell me the direction I'm going in. The length that's traveled by an object, or the length between two points, is the distance. And the distance symbol we use is the small d. This triangle means change, so the change in distance. The units that we use are meters. If you have other units, you need to convert them back to meters. A vector is different. A vector describes both the magnitude, which is the amount, like the 12 meters or 1,000 kilometers, but it also tells us the direction of the motion. So we have to know if we're going east or west or northwest, positive or negative direction. The quantities that we'll use are position and displacement. So distance was only the number. Displacement is going to tell us the number and the direction. We have to know the home base when we talk about displacement. We have a reference point. The position is given with the small d again, but there's something different. You'll notice that there's an arrow on the top of the d, and this tells us that a direction is involved. This is a vector quantity, so we must include direction in our answer. Displacement is kind of like distance. It refers to a straight line from one point to another. However, it doesn't tell us the total distance traveled. If you run around a track 400 meters, then you've gone 400 meters as a distance, but your displacement is 0 because you're at the same point you started at. When you go to school every day from your home to school and back, your distance could be 3 kilometers, but your displacement is 0 because you're back at home. Again, our displacement symbol is the change, remember triangle change, and the small d for distance, and we have that arrow again. The arrow tells us that it is a vector quantity and we need to have a direction. The units are in meters. So to calculate distance, this is easy. You've done this lots. You just add up all the distances regardless of the direction they go, and you see how long it is. So if Susie goes to McDonald's, oh boy, that's not very healthy, but she has to travel 135 meters to school. Then at lunchtime, she must have a longer lunch than us, she travels 40 meters to McDonald's to get a mixed snack wrap. That sounds healthy, but it's not. After lunch, she travels back to school, and then after school, she travels 350 meters to her friend's house. So how far has she gone in the whole day? As I'm sure you already know, you just add up all those numbers. So here is our quantity for distance. Notice there's no arrow, so this is just distance. We do not need a direction with it. So we're going to add up all the distances. Oh, look, there's Susie and her friend. They're eating a lot of fries. So we put the 135, 40, then 40 back to school, and then the 350 to her friend's house. And if you add that all up with your calculator, you get 565 meters. Ronald McDonald is super happy. So here's the change in distance. And we have the number as well as our units. If we want to calculate displacement, this is different. We have both the magnitude and the direction. but we have to use vectors. Here's some important information in this table you may want to write down. We need to know what the signs are to assign for our math. If you are going up or north, we give that a positive quantity. If you're going right or east, this is also positive. So the opposites of those would be going either down or south, which gives us negative, or left or west, which gives us also negative. So we have a tip-to-tail method for vectors that we use. We also use math for this. So our question here is about this ant, and he goes to find some food for his ant family. He has to go 6.3 centimeters east, which is a long way for an ant because they're real small, and he picks up the grain of rice. Then he realizes that it's close to his home. He travels back 3.2 centimeters directly west in order to bring his grain of rice back to his friends at the ant colony. We want the total displacement in this case. So displacement, we think of vectors, we need to have direction. So we need the change in displacement. There's that arrow, so we know it's a vector quantity. To use the vector method, tip-to-tail method, we have to draw an arrow which is exactly 6.3 centimeters long going east. And this is, if I think of north, east, south, west, my arrow head goes towards the east. I then put the 3.2 centimeters directly west. This is my second displacement. Now he goes 6.3 centimeters away from his home, then 3.2 centimeters back. We only want to know the red arrow. What is the difference between those two? Where is he now in relation to his home? So if I subtract those two, I will get his resultant displacement. Look at that arrow again, displacement in centimeters. So I put in the numbers, east and west, my directions have to be there. And if you recall from my last slide, what is east and west for the signs, you will remember that 6.3 east is positive and 3.2 in the west is negative, which makes it really easy to subtract those two things and get 3.1 centimeters positive. What does that positive mean again? It means east, 3.1 centimeters east. So that's how far the ant is from his home now. That's his resultant displacement. His distance would be different. There he is, super happy, and all his friends love him. Last question here. Here we have this man. He's having a little rest on a bench in the park, but he perks right up when he sees some garbage to his right. So he travels 11 meters east and picks it up. Then when he's coming back to his seat, there's the garbage can. So he travels 5.4 meters west to throw out the garbage. What is his total displacement from his seat? So displacement, this is a vector quantity, we need direction. Here are my arrows again. It tells me that he went 11 meters east. So my arrow is going to the right, it's positive. 5.4 meters west, it's going this way. I care about the difference here. Where has he gone from his bench seat, which would be here? I have to subtract the two. So I have 11 meters east, 5.4 meters west. I assign the signs, which are positive and negative. Then I can easily subtract those two to get 5.6 meters. Positive direction, which means 5.6 meters east. Yay, you did it! And there he is, happy he threw out his garbage. That is the end of our video for this lesson. So please go back and review if you need to. Write down the different definitions, write down the examples so that you can be a pirate tomorrow.